All right, 7.5. We're now solving rational equations. The first part, we were always dealing with rational expressions. Now we've got this new word, equations. Equations means got an equal sign and two expressions that are together. So it's equal sign in the original question. We're also being asked to solve, which is different than what we did in the first part. The first part was simplify, and that we got down to the end and we still had an x in the answer. Solve means now find the value of x, or whatever variable you have. We're looking for what is the value. So just like regular solving, get what x equals. So let's start with our basic. Get the x's to one side, get your numbers to the other side. Doesn't matter which way you move them. I'm going to just move them to the left. You could move it to the right, doesn't matter. Get x's on one side, numbers on the other side. So I'm just going to go subtract 3x. I'm going to subtract 2. So then I get 2x minus the 3x gives me negative x is equal to negative 6. And just divide by the negative, so x is equal to 6. Next one. Well, let's subtract the 3 over. That's going to give us x over 4 is equal to 4. And now we multiply both sides, do the opposite. If we're dividing, we do the opposite. Multiply by the 4. And we get left with x is equal to 16. For this next one, there are two different methods of doing these. One, which is really the same type as what you did in your first part, is get a common denominator. So method 1 is get common denominator. So the way that that's going to look is we need to get this part, 3 and 4, into a 12. So I need to multiply this one by 4 over 4. I need to multiply this one by 3 over 3. So same thing as what we were doing before. So we get 4m plus 9m is equal to 13. Add your numerators there. 13m over 12 is equal to 13. And now we're going to multiply the 12 up to the other side. And then we're going to divide by 13. I'm not going to waste my time going 13 times 12 and getting that, because I can look ahead and say, I'm going to divide by 13 right away. So when I divide by 13, I just have to go like that and say that m is equal to 12. I didn't need to figure out what 13 times 12 was and then divide by 13 again. So there's method number 1. It's getting a common denominator. Method number 2, which I'm going to focus more on, is it's a little bit easier. Is method 2 is multiply all, and I'll underline all terms by the LCD. So it's very similar to method number 1, just looks a tiny touch different. You can only do this when you have an equation. This method only works for equations. And there's an equal sign. So we find that the LCD is equal to the 12, which we already identified in method 1. And so we're going to take it. I'll just rewrite the question. Multiply every term by the LCD. 12, 12, 12. This is where it's slightly different than what you did with expressions. I don't need to multiply by 4 over 4, 3 over 3. I'm just multiplying by 12. I'm doing the same thing to both sides of the equation. As long as you do the same thing to both sides of an equation, it's still going to be equal. And now we just hiya from here. Divide first. 12 divided by 3 leaves me with 4. 12 divided by 4 leaves me with 3. Don't forget you have to multiply on this side as well. So now let's write what we have left here. I've got 4m plus 3 times is 9m. Notice that that's the same thing that you're getting here, is equal to 13 times 12. Notice that that's the same thing you're getting here. It's just two different ways of showing the same thing happening. Whichever way makes more sense to you, use that one. I'm going to focus on method number 2 when I show the work all the way through. If you want to, you can multiply 13 times 12, 156, but I'm just going to look ahead because I already know that that's going to be a 13. And then I'll be dividing by the 13 to get m is equal to 12. Let's apply the exact same strategies to when there's variables in the denominator. So I highly recommend that you try these ones first yourself. See if you actually can figure it out. You learn way more if you try yourself. So method number 1 would be find the common denominator and make everything a common denominator. Most people don't really care for fractions. That's why I focus on method 2. Find out what the LCD is. So the LCD between 3x, 4, and x is going to be 12x. And now multiply every term by 12x. So put brackets around every term. Put a 12x there. And divide before you multiply it. You always need to divide before multiplying. The whole purpose of this is to get rid of the fractions. If you don't get rid of the denominators, then you did something wrong in this step. So the x and the x cancel off. 12 divided by 3, hiya, gives me 4. I now have left for this one is 4 times 5. Plus 4 and 12 cancel off. Gives me 3x still there. So then I get 3x times the one that was already there. Equals. You have to make sure that you don't forget to multiply every term by the LCD. So let's divide first. This one, the x's will cancel off. I get left with 12 times the 3 that was there. And now this is just regular junior high solving. 5 times 4 is 20 plus 3x equals 12 times the 3, 36. And just solve for the x. Take your numbers to one side. So let's subtract 20. Subtract 20. 3x is equal to 16. And then divide by 3. So x is equal to 16 over 3. Just have to look at, make sure, what were the NPVs. Gotta always look at NPVs for all of these. Okay, so we've got 0. So x cannot equal 0. You got to write that because you just have to check to make sure every now and then your answer is the NPV. And then you got to say, well, it can't be that answer if I've already said it can't be. So it's a good idea to do your NPVs first. Right off the bat, x cannot equal -2 and 4. Got to make sure when we get to the end that our answer is not -2 or 4. So, LCD on this one. We got an x plus 2 times x minus 4. We're going to multiply both sides of this equation by that LCD. So we'll bracket them off. Got to multiply every term. So then that's x plus 2 and x minus 4. X plus 2 and x minus 4. Divide first. The whole point is to get rid of the denominator. Hiya the x plus 2's, hiya those x minus 4's. Leaves us with 6 times x minus 4 equals 4 times x plus 2. Now it's just distribute in. And solve for the x. So we've got 6x minus 24 is equal to 4x plus 8. Okay, and bring over minus 4x plus 24 plus 24. So 2x is equal to 32. Divide by 2. X is equal to 16. And before you box it in, just check to make sure 16 is not one of those NPVs. No, it's not, so 16 is good to go. Okay, to solve an equation with rational coefficients now. The fractions can be cleared by multiplying both sides of the equation by a common denominator. And that's exactly what I was just showing. So, example here, how we can work with. We're going to get rid of those denominators right off the bat. And that's a much more efficient way to go through it. But if you want to take it to common denominator on either side, go ahead, that will work as well. So the same strategy we can use to solve the rational equations, just like I said. But I'm going to have you start and make sure that you write this down. Do not use this method for rational expressions. So, not for rational expressions, only for rational equations. And again, equations are the ones that have the equal sign in the original question. If there's no equal sign in the original question, you cannot use this method. And that's where lots of people make the mistakes. Is that now that they learn this method for equations, they apply it to expressions, but it cannot be used for expressions. And again, don't forget, you got to look to make sure that your solution is not extraneous. Your NPV and your solution cannot be the same value. All right, so step number 1. Make sure that you have an equation. Yes, I have an equation. I can then use this second method. Figure out what your LCD is. 2x, 5, 10x. That LCD is going to be 10x. Multiply all terms by 10x. Divide before you multiply. So The x's cancel off. 10 divided by 2, that gives me 5. I'm left with 5 times 1. Minus 10 divided by 5 leaves me with 2x. So I've got 2x times the 2 equals, the 10x and the 10x cancel off, 1. This here you could do in your head. You could multiply that and then write it down here underneath. That's fine. 5 minus 4x equals 1, as long as you've got this step written down. And let's just solve for the x. Okay. So let's subtract 5. Leaves this with negative 4x is equal to negative 4. Divide by negative 4. So x is equal to 1. But I got to make sure, and I should have done it right from the beginning, x cannot equal 0. You need to write your NPV down. All right. Let's go through the next one. And it's a good idea to try it on your own first to see if you can do it yourself. LCD is equal to an x squared, and a 1. So it's going to be x squared. Let's multiply every term by x squared. X divided by x, which is x squared over x, gives me just x. X squared over x squared, cancels gone, and this one still stays. So we've got left here with 5 times the x, 5x, plus 6 times 1, so it's just 6, equals 6 times the x squared, 6x squared. We have an x squared. Anytime you get a quadratic, it means the x squared, quadratic. So, anytime you get quadratic, you need to do what we did in the other chapter there, the quadratic solving. Equate to 0 and factor. Or you can use quadratic formula or complete and square or any of those other ones. But we're going to focus mostly on factor. We want to move it so that the x squared is a positive coefficient. So I'm going to move them over that direction. So 0 is equal to 6x squared minus 5x minus 6. And then we factor it. Okay, use your sum product factoring. I'm not going to go through that because you should by this point be very good at factoring. So we get factored form 3x plus 2 and 2x minus 3 equals 0. Please practice factoring yourself. Make sure you get this. Pause, make sure you get this, and then keep going. If you don't, find out where you're going wrong. And then we solve. So 3x plus 2 equals 0. 3x equals negative 2. X is equal to negative 2/3. Or 2x minus 3 equals 0. 2x is equal to 3. X is equal to 3 over 2. Are either of those the NPVs? The NPV that we had at the beginning was x could not be equal to 0. So those ones pass. So there's 2 answers. So x is equal to negative 2/3 and positive 3/2. Okay, so just some information for yourself on how you can use your graphing calculator to help you to verify that your answer is correct. Left side, right side. Same as any other verifying. You're taking the value that you set as your answer and then plug it in for your x value. here's the step-by-step play of how to do it on your calculator. Storing values. And I taught you how to store already. So put it in there, store into your X, and then hit enter. You could also do it by storing it into A or B or C or whatever variable you want all the way through your calculator. We're just going to store it into the X. That's putting the X equal to negative 1/3. Then all you're going to do is you're going to plug this into your calculator. 5 divided by 2x. 5 over 2x. Make sure it's in brackets. All denominators, if it has more than one thing, has to be in a bracket. And all numerators as well. Plus 3 over 4. So I did there. Oops. Not that color. Left side and right side. And you have to make sure that they both come out to the same answer. Okay, so suppose a graphing calculator is not available. How can you check it if you don't have a graphing calculator to use? To be able to store in that value. Well, just verify the same way as always. Substitute X equals whatever you've gotten, and that question was negative 1/3. Substitute the X equals whatever into both sides of equation to make sure they come out to the same thing. All right, so here we go again. Solving in each equation. Exactly the same thing. Find your LCD, multiply both sides by the LCD. So I'm just going to quickly look. My X cannot equal negative 2 or positive 3. My LCD is X plus 2 multiplied by X minus 3. I'll just multiply both sides of the equation by the LCD. Back it off every term and multiply by X plus 2 and X minus 3. X plus 2 and X minus 3. Divide first. So X plus 2 packages, the whole package cancels off, and the whole package cancels off. I now have negative 3 times X minus 3 equals 2X times X plus 2. Expand. Collect like terms. So we've got negative 3X plus 9 is equal to 2X squared plus 4X. Got a quadratic. As soon as you got a quadratic, equate to 0 and factor. Take it so that your leading coefficient is positive. So 0, I'm going to take it over to the right. 2x squared plus 7x minus 9. And then we factor that. So again, if you're struggling with factoring, please get some help on that. So factored form. Make sure that you do factor and you do get that same answer. And then, so x is either equal to 1 or 2x plus 9 equals 0. 2x is equal to negative 9. X is equal to negative 9 over 2. Last thing you have to do is check. Do either of these two answers show up in the NPVs? No, they don't. So those are my two answers. So x is equal to 1 comma negative 9 over 2. B, try it yourself. And then check to see if you're getting the same answer that I'm getting. But pause it, try it yourself. NPVs, and your LCD is equal to x minus 5 times x minus 1. And expand your numerator. So on the left side you get x squared plus x minus 2. On the right side you get x squared minus 5x. You've got a quadratic, so we've got to equate to 0. Nice thing with this one is when you equate to 0, the x squareds are going to cancel off. So you're going to get 6x minus 2 is equal to 0. So then you just start solving for the x. 6x is equal to 2. So x is equal to 1/3. Only one answer for this one. Check to make sure. Is that one of the NPVs? No, it's not. Box it in. All right, last one here. First thing before you even start, factor. You can't factor numerator. I can factor that one, so I'm going to get 7x minus 15 over x minus 3, x plus 3 equals x minus 2 over x minus 3. Okay, NPVs on those ones, x cannot equal plus and minus 3. LCD on this one, x minus 3 and x plus 3. So multiply both sides by that. And nice. All of that one cancels off. Just that cancels off there. And we get left with 7x minus 15 is equal to, expand these two together. Either write it again and expand it, or I'm going to just do it right from here. Remember that this has brackets around it. Got a quadratic, equate to 0 and factor. Move it to where the x is positive. 0 is equal to x squared minus 6x plus 9. And then factor. So then x minus 3 times x minus 3 is equal to 0. Those are the same. So really x minus 3 squared is equal to 0. So then I can say x minus 3 equals 0. So x is equal to 3. But whoa, wait a minute. You said right up here at the top that x couldn't be positive or negative 3. And then now I'm saying x is equal to 3. If the NPV and the solution are the same, there is no solution. That's why you have to write the NPVs down. So there's no solution. Next to that, no solution since the answer is one of the NPVs. All right, number 3. First step, factor. So negative 10 over the factored form, x minus 7, x minus 5 equals x over x minus 5. Now do your NPVs. X cannot equal 5 and 7. And your LCD is equal to x minus 7, x minus 5. Multiply both sides. Both of those cancel off. That one cancels off. We get left with negative 10 is equal to x going into there. So x squared minus 7x. Okay, if you want, you can write the line in above. That is that, if that helps you out. Equate to 0 and factor. Make sure that you are practicing your factoring here. So we've got negative x minus 2 and x minus 5. So then x is either equal to 2 or 5. But always have to make that final check. Are either of these solutions an NPV? And 5 is one of them. So we cannot include 5. The answer is just x equals 2, and that's it, not the 5. Last one. Factor, then multiply everything by the LCD. Try it yourself. This is a big, long one. If you can do this one, you can do them all. So the factored form of that is x plus 6, x plus 4. You probably could have guessed that, because they like to make them all the same. So now, NPVs, x cannot equal negative 6 and negative 4. LCD is equal to x plus 6 and x plus 4. So bracket off each one of them. Each fraction, x plus 6 and x plus 4. X plus 6. And I'll put on this side x plus 4. X plus 6 and x plus 4. And then start hacking it. X plus 6 is gone. X plus 4 gone. Both of these babies, bye-bye. And we get left with, I'm going to rewrite this one out just so that you can see what we have. Plus. Careful if that's a minus, because you're going to have to distribute that in as well. And now expand. Collect your like terms, factor. And we get x squared plus 5x plus, oops, no, good. Oops, plus 4. Plus, and careful, if that was a negative, you'd have to be distributing that into here as well. Plus x squared plus 4x minus 12. So it actually is safer if you have the brackets there, because if that was a negative, you'd bring it in. Equals 11x plus the 32. Equate to 0. When we bring it all together, 2x squared minus 2x minus 40 is equal to 0. And factor. Okay, well, I can factor 2 right now. So if I factor out a 2, in other words, divide everything by the 2. I get x squared minus x minus 20 is equal to 0. And then when you factor that, x minus 5 and x plus 4 equal to 0. So then x is equal to 5 or negative 4. But always check, are any of those the NPVs? Ah, yeah, negative 4, that's a no-go. So then x is equal to 5 is your final answer.